These are the setups for the lab on forces. I'm just going to go verbally through them so that you get a better idea of how long these vectors are and how at what angle they are. And I don't want to write that down, so I want you to, well, look at this recording here. Okay, of course you have to label them, so I'm not gonna say what they are, but you have to figure that out. So this one here is looks like it's 1, 2, 3, 4, 5, 6 squares long. Notice the scale here. 1 square equals 1,000 newtons, and then there is also a ruler that says between 4 and 10. So yeah, 6,000 newtons. This vector here to the right. This vector 4,500 newtons up. This vector 3,000 newtons to the left. This vector 9,000 newtons down. This vector 4,500 newtons up. This vector 3,000 newtons to the left. Okay. Next one, now the same car on a bump on the grass. This vector at a 45-degree angle and 6,500 newtons. This one here, a 45-degree angle from the vertical, 9,000 newtons. This one, 45 degrees down below, 3,500 newtons. This vector here, out of the picture, there we go, 9,000 newtons. This one, 4,500 newtons up, and this one, 3,500 newtons to the left. That would have been the same. That was actually my example calculation, so I don't have to do that again. This one, 9,000 newtons down. This one, 4,500 newtons up. Same, this one, 4,500 up. This one, 3,500 newtons to the left. And this one is same, 3,500 newtons to the left. Okay, and notice again the scale. 1 square equals 100 newtons. So this vector down at 200 newtons, this vector up at 300 newtons, and this vector to the left at 50 newtons. This here is before the parachute opens. Notice each square is 500 newtons. So 1,000 newtons down, 1,000 newtons up. Again, that's without the parachute. And then the other one is with the parachute open, 1,000 newtons down and 2,000 newtons up. So this is the pendulum. The scale is 1 square equals 1 newton. So this one is 2 newtons down, and this one is 3 newtons to the upper right at an angle of 60 degrees. And in the description you read that the string is at an angle of 30 degrees, but that's from the vertical. So the force vector is at 60 degrees from the horizontal. Here each square is 5,000 newtons, or you can just look at the ruler and you can see that 2 squares would make 10,000 newtons. So this vector is 25,000 newtons down, and these two vectors to the upper left are 15,000 newtons each, because this would be 1.5 15,000, and they're at an angle. The incline is an angle at 30 degrees, which means the vectors to the upper left are an angle of 30 degrees from the vertical, or 120 degrees from the horizontal. The 120 is hidden behind the arrow. Okay. Each square is 1,000 newtons, so this vector is 6,000 newtons. To the up, of course, this one to the right is 1,000. This one to the left is 1,000. And this one down, I have to move it into the picture actually, is 6,000 newtons down. Same scale on this one. So this vector up is 4,000 newtons. Vector to the right, 1,000 newtons. Vector to the left, 500 newtons. And this vector down, 6,000 newtons. And that was also what I used in my example. So this one, the scale is 100 newtons per square. So this force is 200 newtons to the right. This one is 200 newtons to the left. This one is 500 newtons up. And this one is 500 newtons down. And these were verbally the vector lengths and at what angle each one of them is for the slab on forces.